right, so now we're ready for part 3, conservation of linear momentum during a inelastic collision. So a inelastic collision means that the two are going to crash into each other and then stick together. So there's not going to be any bouncing off. And they're going to stick together, so pretend there's glue that's going to hold them together once they come together. So that's going to be the inelastic collision. So we're going to need to go back to the simulation here and click on inelastic collision. Okay, here's the two cars, and then let's just show you what's going to happen. So I'm going to hit the start button. Oh, and nothing happens. Why do you think that nothing is happening? Because my initial velocities were 0. So they're just sitting there. So that was a pretty boring experiment. All right, so let's reset it. And then this time, let's give this one. Now, should I give it a positive velocity or a negative velocity? Well, we want it to collide with this one, so I better give it a positive velocity. And if we want it to hit this one, now if I gave this one like a velocity of 1, or then the blue one would start going this way, but eventually the red one would catch up with it. But unfortunately, it would probably do it off the page over here. So it's probably better just to have the red one going this way and the blue one going this way. So that means that the blue one needs to have a negative velocity. Okay, now we can hit the start button and they stick together, and now they have a combined final velocity of 1 meter per second. So that's what's going to happen when you play with this simulation. So if we go back to here, and then go down to here, let's look at what conservation of momentum would look like for a collision. So this time we're going to have the momentum of the red one, so mass of the red one times the velocity of the red one initial plus the mass of the blue one times the velocity of the blue one initial has to equal the total momentum afterwards. So that when they're stuck together, we could say that this is going to be the mass of the red one plus the mass of the blue one because they're stuck together, and then multiply that by the speed of, like, the total speed afterwards, so final. Now, does that look kind of familiar? So if you look at this equation right here, and then you take this and you move it over to this side, and then you take this and you move it over to this side, it's the same equation that we had for collision, the explosion. So this formula here is the same as that formula up there. It's just flip-flopped. So we're doing a collision, which is kind of the opposite of a explosion. So here's how you're going to start. Select a mass of 2 for the red one. Select a mass of 3 for the blue one. Select a initial velocity of 2 for the red one. And now notice this is negative. So -5 for the blue one. Calculate the initial momentums for this one, the red one, and the initial momentum for the blue one, and then add them together, and you'll get this number down here. And then click the go button, click the start button, and look at what the final velocity is after they're stuck together, and then put that here, and then calculate the final momentum of the system. So to get the final momentum, you're going to take the final velocity and then multiply it by the sum of the two masses. And then take a look at this number and compare it to this number here. So question 3, how does the sum of the momentums of the system compare to the final momentum of the system? Was momentum conserved? Okay, now we're going to reset the simulation. So notice I changed the masses and I changed the velocities, and you're going to calculate what should be the final velocity of the system. You're going to calculate it using this equation, because you're going to know this and this and this and this, and you'll know that, and then you can solve it for that. And then you're going to actually watch the simulation and put that number here, and then hopefully the two numbers will be the same. So you're going to calculate it, and then you're going to do it on the simulation and then observe what the final speed was. All right, now we're ready for part 4, conservation of linear momentum during an elastic collision, and we'll do that in just a moment.